All right, here's solutions for quiz 6 for Math 243, kind of a longer quiz. This first question, you're told that 2% of all iPads are defective. So that's giving you P here, the population proportion. It's 0.02. And we have a random sample of 2,000 of these guys. So that sounds like N is 2,000. And in this random sample, we want to figure out the probability that less than 30 of that 2,000. So when you see this 30 here, you're thinking 30 out of 2,000, which is 0.015, I believe, 1.5%. Less than 30 of them will be defective by following the steps below. State and justify the shape of the sampling distribution, then center and spread. Sure. Shape, normal or approximately normal, either way is fine. And the reason why is because N times P times 1 minus P is greater than or equal to 10. And center, it has a fancy symbol. If you can get that, great. If you just know that it's equal to P, which is 0.02 in this case, that's pretty good. And then the spread also has a fancy symbol, sigma sub P hat, and it's given by a formula, specifically P times 1 minus P over N, square root of that. So in this case, the square root of 0.02 times 0.98 divided by, what was N in this one, 2,000? Sure, this guy here. All right, and I'm supposed to depict my answer with the appropriate picture, make note of any calculator functions used. I can do that. There's my distribution. Approximately normal, as stated above. Good enough anyways. And in the center, I have 0.02. And what I want is less than 0.015. So I don't know, 0.015 is somewhere out here. And less than that would be this area. So to figure that out, I use the normal Cdf function in my calculator. Don't have a lower bound, so I trick my calculator with any large negative number. Upper bound would be 0.015. Center would be 0.02. And the spread would be 0.02 times 0.98 divided by 2,000 square root. Let's see what that's equal to. Well, we want the normal CDF function that's under the distribution menu, so second then variables. Grab normal CDF. The lower bound is any large negative number will do. The upper bound is 0.015. The center is 0.02. And the spread is this expression, the square root of 0.02 times 0.98 divided by 2,000. And we'll see what comes out of there. Pretty small, 0.05, 0.0551, I guess, or 5.51% if you're stating it as a percentage rounded to 2 decimal places. Guess I didn't ask you to this time, so either of these would be fine. All right, second question. Suppose that you don't know the proportion of all iPads that are defective, but we do have this sample of 2,000. So that's my value of N. And in this sample of 2,000, 1.7% of them. So P hat, the sample proportion is 1.7%, or 0.017 if you want a decimal. And so that tells you that X, which is always P hat times N, would be 0.017 times 2,000. So what is that, 34? And what I'm supposed to do is create an 80% confidence interval for P by following the steps below. Shape, center, spread. This is annoying. Sure. Shape, normal, or approximately normal. Same reason as above. N times, instead of P, it's P hat. Times 1 minus P hat, which is greater than or equal to 10. Center and spread are also similar. Except instead of P, I'll use P hat. My point estimate. So the spread would be the square root of 0.017 times 0.983 divided by 2,000. And you don't need to calculate that. Picture the distribution. All right. Here's my distribution. Point estimate. That's 0.017. Level of confidence or level of certainty, that is 80%. So the bounds, I don't know them, but I can get them straight out of my calculator. You go to stat and then tests. And this is a 1 prop z interval. There it is. And it asks you for x, n, and your level of confidence. So x is 34. And n is 2,000. And my level of confidence is 80 is 80%. Good enough. Hit calculator, should spit out my answer for me. 0.0133 up to 0.0207. State my conclusion. I am 80% sure, or confident, or certain, or whatever, that between these two numbers that I just wrote, as percentages, they're 1.33 and 2.07% of, and then just to make it clear, I'm talking about the population. Maybe I will say of all what iPads are defective. Seems high, but whatever. So there's a conclusion. Then finally, a third problem. Let's see, we did the normal CDF stuff. We did the confidence interval stuff. So you won't be shocked to see a hypothesis testing question. We're again supposed to assume that 2% of all iPads are defective, except now this isn't P, it's P naught, because I want to save P for something else. I still have a sample of 2,000, so that's N. 44 in my sample, that's X. Test the claim that buying an iPad off Amazon increases the probability that it will be defective by following the steps below. 95% certainty tells me that alpha is 5%. So the Nolan alternative hypotheses, these always compare P and P naught. P will always be the symbol P. P naught will always be a number given in the problem. Null hypothesis is always that those two things are equal. And for my alternative hypothesis, I either have a less than, greater than, or it does not equal sign. This increases word here is what clues me off that it's a greater than sign, and this is a right-tailed test. It's optional. You don't have to write that it's right-tailed, you just need all this stuff. Shape center spread for the third and final time. Annoyingly, I'm going to write this stuff. Shape's normal. And then center in the spread. Essentially, what I'm going to do is copy exactly what I wrote here, except change all the P hats to P naughts. So it's normal because N times P naught times 1 minus P naught is greater than or equal to 10. The center is P naught, which in this case was 0.02. And the spread is the square root of P naught times 1 minus P naught over N, which is 0.02 times 0.98 divided by 2,000, whatever that ends up being. Appropriate picture of the p-value method of hypothesis testing. Nice. Classical's a little bit more tedious than p-value. Need to do a couple extra steps. It's late at night. I'm happy to just be doing the p-value here. What I can do for the p-value picture, start out with my normal distribution. Since I'm writing normalized values, I'll throw a 0 in the middle. Go to stat and then test. It's a 1 prop z test. Fifth thing listed here. P naught is 0.02. X is, as I have written up here, 44. And N is 2,000. And my claim is that P is greater than, so this third option, P naught. And I'm going to do draw, because then it will draw for me the picture. There it is, big old p-value. Here's my test statistic here. Z is equal to 0.6389. And this area to the right of my test statistic, to the right because it's a right-tailed test, is my p-value. In this case, it's like 26%, 26.15%. Point is, it's bigger than alpha, right? Because alpha was only 5%. It's quite a bit bigger than alpha. So I would say because my p-value, if you want to restate it, you can. 26.15% is greater than alpha, which was a measly 5%. There is not sufficient evidence to reject the null hypothesis. So I cannot conclude whatever the claim was, that an iPad bought off Amazon is more likely to be defective. And that's that. That's solutions to this quiz.